Today we're going to discuss section 3.3 of our Algebra 1 BJU Press textbook. We're going to be looking at similar figures and then also be looking at some scale drawings. Let's go ahead and start with a refresher on how to solve for squares and cubes. If I have x cubed equals 64, I'm thinking, what can I do cubed in order to get 64? So something times something times something, and it has to be the same thing. I need to be multiplying by itself 3 times. Well, let's try 2. 2 times 2 times 2, that's 8. So that doesn't get me 64. What about 4? Well, if I do 4 times 4, that's 16, and then I do 16 times 4, that gives me 64, which means that x is equal to 4. Let's do 49 over 64 and equals x squared, and I want to solve for x. So again, I'm thinking, what over what, if I square it, is going to get me 49 over 64. So I know I want to be a fraction, so I need something in my numerator that when I square it is 49. And I need something in my denominator that when I square it, it becomes 64. Well, I know 7 squared is 49, and I know 8 squared is 64. So that means if I do 7 over 8 squared, then that means I get 49 over 64. That means x is equal to 7 over 8. Let's look at these. These are a little bit more difficult. So on the left-hand side, I had 27 over 8 equals x cubed. So again, I need something over something where if I cube the numerator, I get 27. And if I cube the denominator, I get 8. Well, 3 cubed is 27, and 2 cubed is 8. So that means that x is 3 over 2. Over here on the other side, this is really tricky. I need something where 10 over that number and then squared equals 25. So I know that 5 squared is 25. So how do I make 10 over x be 5? Well, 10 over 2 is 5, which means that x has to be 2. Right, one more like that. Okay, I want 1 over 8 to be equal to x over 14 cubed. So this is really tricky because I want to cube something where my final answer is going to be 1 over 8. So this time it's going to be 7. And the reason why it's 7 is because I wanted something that would reduce to 1 over 2, because 1 over 2 cubed is 1 over 8. So if I do 7 over 14, that reduces to 1 over 2, which when I cube 1 over 2, I get 1 over 8. So let's look at some definitions. We'll start with similar figures. Similar figures have the same shape. So for example, they could both be triangles, but they're not going to be the same size of triangles, just they're both triangles. If you have similar polygons, that means they are polygons in which corresponding angles are congruent, which means equal, and corresponding sides are proportional. Proportional doesn't mean equal, it just means that one is in proportion to the other. So here's the notation for similar. It's a little squiggle. So if we had two triangles that we want to say are similar, we would write this. Triangle ABC is similar to triangle XYZ. And when we write it, we have to make sure that we write it in the order that they're similar, because we're going to say that angle A is similar to X, B is similar to Y, C is similar to Z. Those have to match. So corresponding vertices must be written in corresponding order. And also, if you have similar polygons, it means that those angles are congruent. And that's why it's so important to write them in the correct order, because if you're saying A is similar to X, then you're saying A is congruent to X, which means that the angle A is equal to angle X. So likewise, B is congruent to Y and C is congruent to Z. And then remember, we also said that the sides are proportional. And proportion, remember, is a statement in between two ratios. So the ratio of A to B to XY, so AB over XY, has to be equal to the ratio of BC to YZ, which I wrote BC over YZ, which has to be equal to the ratio of CA to ZX. So let's say that we have a figure where we have this proportion. We have CA over ZY equals AB over XY. And we want to solve for this length. We want to solve for the length of XY. We know that CA on this figure is 5. And we know that ZY in the second figure is 2.5. And we're going to set that equal to our first figure has AB as 5.7, and the corresponding side of the second figure is XY. Well, we don't know that measurement, but we're going to solve for it, and we can use what we learned in the last lesson using proportions. So we're going to cross multiply. So we have 5m is equal to 2.5 times 5.7. So we're going to solve for m. 2.5 times 5.7 is 14.25. We divide both sides by 5, and we find out that m is equal to 2.85. So again, if we can set up a proportion, let's say, remember the BC and the CA, those come from the first figure, whereas the YZ and the ZX come from the second figure. Just make sure that if you put BC on top for your first ratio, that same figure goes on top in your second part of your proportion. So for this one, we need to solve for the side YZ, knowing that side BC is 7.25, that CA is 5, and ZX is 2.5. So we cross multiply. 7.25 times 2.5 is 18.125. We divide both sides by 5, and we end up with our missing side is 3.625. Let's say that we want our perimeters are both figures. Well, the perimeters is where we add up all the sides. So if we add up all the sides of the A, B, and the BC and the CA, we end up with 17.95. We just calculated those. If we add up the sides of XY and YZ and ZX, we just calculated those, and that will end up being 8.975. So now we know the perimeters of each. And if we want to know the ratio of the perimeter, we just do 1 divided by the other. So 17.95 divided by 8.975, and that reduces to 2. So the ratio of the perimeters is 2. And we also notice that the ratio of the corresponding sides is also 2, which leads us to our next theorem. The reason I know that the ratio of the corresponding sides is 2 is I just took corresponding sides. So for example, CA was 5 and ZX was 2.5, and I made that ratio, so 5 over 2.5, and it ended up being 2. We have the theorem that in any similar figures, the ratio of the corresponding lengths, including perimeter, is equal to the ratio of the corresponding sides. Sometimes you're going to be dealing with real real life objects. So you're going to have units. So you're going to want to be able to convert different lengths depending on what's the easiest to work with and what's convenient. So for example, in example 3, it's going to be most convenient to convert to feet. You don't have to convert to feet, but if you don't convert to feet, you've got to convert to something else. So your units have to match before you can work with it. So if you had 5 foot 3 inches, you would want to convert that, and that would be 5.25 feet. So you would have to use your previous knowledge of dimensional analysis, which we learned in the last lesson, on how to convert 5 foot 3 inches to feet. So 1 foot 6 inches, we would convert to 1.5 feet. And so now we can go ahead and solve our problem. If we know the height is 76 here with a length of 1.5, then what's the height here if this was 5.25? So we'll cross multiply. All right, so let's say we want to find area. So in order to find area, we have to know that the ratio of areas is equal to the square of the ratio of corresponding sides. So remember, perimeter was just the ratio of 2 sides, but area is going to be the square of the ratio of those 2 sides. And volume is going to be the cube of the ratio of those 2 sides. So let's look at example 4. We have the ratio of lengths as 2 to 3, which means that the ratio of areas is going to be 4 to 9 because you're going to square them, which means that the ratio of volumes is 8 to 27 because you want to cube it. So if we want to find the area of the base of the larger prism, we need to square it because we have to square areas. So we know that our first one is 36. Our small one has an area of 36. And we want to know what the area of our larger prism is. Well, we set that equal to the ratio of areas, which was 4 over 9. Now we can cross multiply and solve for the area of our larger prism. If we want to find the volume of the smaller prism, we set up this proportion. We need the volume of the smaller prism over the volume of the larger prism, which we saw was 1,215. And that we will set equal to the ratio of volumes, which was 8 over 27. Then we cross multiply, and then we can solve for the volume of the smaller prism. So the area of our larger prism was 81 units, and the volume of our smaller prism was 360 units. Make sure you include any appropriate units with our answer. If they don't give you units, go ahead and say units squared or units cubed, depending on if you're talking about area or volume. All right, let's talk about scale drawings now. Scale drawings are two-dimensional, such as maps, blueprints, or diagrams. So this is not going to be 3D, it's only 2D. It's two-dimensional. Models are what we consider three-dimensionals. So the difference between scale drawings and models is that scale drawings are two-dimensional and models are three-dimensional. So the scale of a drawing or a model, so again, scale can be talking about drawings or models, so 2D or 3D, is the ratio dimensions of the drawing or the model to the corresponding dimensions of the actual object. So you have a ratio, and your numerator is the dimensions of the drawing, and your denominator is the real dimensions. So in a scale drawing or model, all the dimensions are in the same scalar ratio to the actual dimensions of the object. So if you know the scale, then you can calculate the dimensions of any scale drawing or model, or if you know the scale drawing or model dimensions, you can actually calculate the actual dimensions of the object. So for example, let's say we know we have 17.5 by 11.25 by 11.5. And we know that it's a scale of 1 to 8. We can calculate the actual dimensions by using our scale. Our scale is 1 to 8. So again, our dimensions in our model was 17.5 over x, which represents the real life length, and we're going to set that equal to our scale, which was 1 to 8. We cross multiply, and we end up that x is equal to 140. So then we do this. That was for when we converted 17.5. Now we have to do 11.25. And we end up with 90. We do the same thing for the 11.5, this part. And we end up with 92, which means that our new dimensions for the real life object is going to be 140 by 90 by 92.